Here's another question to do with a helicopter taking off. It takes off at speed, acceleration of 1.5 meters per second squared. And the helicopter weighs 1 ton. What thrust is the engine producing? Well, first of all, start off with a diagram. It doesn't mean draw a pretty picture of a helicopter. It just means just consider a mass. And once it's taking off, we've got no reaction from the ground, so we will assume it's taken off and left the ground. So the weight of the helicopter, 1 ton, is 1,000 kilograms. So we've got 1,000 G acting downwards. Now this is quite common to write in your diagram, is 1,000 G is what's needed to express weight. So the weight is 1,000 G. We've got our thrust going up, which we need to calculate. T is thrust in this case. And we've got motion happening. So because of the motion, we've got an acceleration upwards of 1.5 meters per second squared. And we need to form an equation that would actually make this work. But the 1.5 meters per second squared is our mass times acceleration. So MA is my resultant force. Let's try writing result again. So the resultant force is equal to the two forces are acting. So we're going to take positive in the up direction, so show our positive. So our resulting force is equal to our thrust minus the weight. And it's the signs come from our choosing the vertical direction in this. So our thrust T minus the weight, which we can write in as 1,000 G. This 1,000 G is quite common to see when we're talking about weights and things. Don't always convert them because often you'll find G's will cancel. It won't in this case. So my mass is still 1,000. So I've got 1,000 multiplied by 1.5 is equal to the tension minus and 1,000 multiplied by 9.8 meters per second squared, which is gravity. So my thrust going up must be 1,500 plus 9,800. So it's going to be 11,300 newtons. And depending on the question, they may turn around. They may have asked you to do things with the acceleration, like I did in the first video, to do with SUVAC situations. But at the moment I'm focusing on forces. Let's do another one. This one is actually a situation where we have an ice skater, and we're going to start off with the SUVAC part of the problem. So an ice skater, mass of 65 kilograms, is moving with a speed of 2 meters per second. 2 meters per second, and holds after 10 meters. And the question is, what's the force, the resistance? Okay, so what's the resistive force? We start off with the situation, we've got a particle moving, so let's show the particle moving. It moves with an initial velocity of 2 meters per second. There's an acceleration backwards that we don't know. and from the initial point to the point where it stops, we've covered 10 meters. Now, a little point on you is, if this acceleration to resist him is by trailing a foot, there is no return journey possible. If this was a bungee jump and he was being retarded, he could actually get a return journey. But in this case, we're going to assume he is trailing his foot. Which leads to friction. The reason I'm making that assumption is to say that the thrust isn't something that's going to keep acting afterwards. So this actually says, when we get to when V equals 0, no forces act. So now the first thing I've got to do is I've got to work out what this A is. So let's do SUVAT. Distance I know, that's 10. U I know, it's 2. V I know is 0. A is what I want to work out, no times. So which equation? V squared equals U squared plus 2AS. Put our values in that we know, so 0 squared equals, and again, let's make our positive direction to the right. U squared is 2 squared. A is a negative A, it's going the opposite way, so it's plus 2AS, and A is negative. So I'm going to find the magnitude of this acceleration. So we're going to get times 10. So A equals 4 over 20, or 0.2 meters per second squared. And we need to work out what force is this. So if we look at the force diagram, the resulting force is, I'm pointing this way, 65 times 0.2 acceleration. There's nothing pushing it forward, pushing back, so that's the only force that's happening. 65 times 0.2. So the resistive force is the mass, 65, times the acceleration of 0.2, which is 13 newtons backwards. Final version is a lift or an elevator. Lift is, well, it's a dumbwaiter lift. That's one of those used for moving food up and down. Has a mass of 4 kilograms. And is a load, has a load on top of it of 10 newtons. We want to know it moves downward. Its initial acceleration. God, my spelling is going bad today. Acceleration of 2 meters per second squared. And the question is, what's the tension in the rope? So we need to draw the diagram. There's my lift. The lift itself has 4 kilograms, so the mass is 4 kg. So 4g is the weight. It's also got an additional mass from inside it of 10 newtons. And we have a tension cable pulling us up. That's my tension in the line. And we're moving downwards at 2 meters per second squared. Why do I keep writing 3s today? So we need to form our equation to see what's happening. That should be weight equals. Let's choose downwards as being positive. So all these things are happening. So my net motion is the mass times the acceleration of the acceleration is equal to everything happening in its own direction, so the weight plus the 10 newtons, which is the load, and then pulling back against that is the tension in the rope. So now I've put in my values. We've got 4 times 2 is the acceleration. The weight is 10. Well, weight is 4 times 9.8 plus my 10 and minus the tension. So rearrange the equation. Tension equals 19.6, 39.2 plus 10 minus 8. So I get a tension of 41.2 newtons in the line. Okay, so there's some simple ones. I'll put another video up for vector equations as well. So that should allow you to do exercise 4C.